Hello everyone. Today we'll be working on section 8.4 transformations. So there are three types of transformations. We have translation, rotation, and reflection. So let's talk about translation first. Translation is sliding an object in a straight path without turning the object. So let's look at this example here. You can see the three corresponding points. So A to A prime, B to B prime, and C to C prime. So the translation here is from A to A prime, it moved 1, 2, 3, 4, 5, 6, 7 units up. So 7 up, and this is 1, 2, 3, 4, 5, 6 units left. And it will be the same for the others. So if you take a look at point B, 7 units up, 1, 2, 3, 4, 5, 6, 7. Okay, and then 6 units to the left, 1, 2, 3, 4, 5, 6. So 7 units up, 6 unit to the left will be the translation from this original triangle to the new triangle here. So we know then the translation will be the same for all of the corresponding points. Okay, next one is rotation. So rotation is a turning motion about a fixed center point. And it can be counterclockwise or clockwise. So if the question does not give you a direction, just give you a degree, then you can assume that it's a counterclock direction. Okay, so let's take a look at this example here. So this is your object, this triangle is your object, and this one is your image. So here you have a 90-degree clockwise rotation. So if this is our original side, then after a 90-degree clockwise rotation, 90 degrees is a straight right angle. So after a 90-degree rotation, this side will become this side. And same for the others. This one after 90 degrees will be this side. And after you have these two sides, you can just connect the third one. And that will give you the new triangle after rotation. And so point A, this point will be the center point of rotation. Okay, next one, reflection. So reflection is a mirror image of an object. Okay, so basically all of the corresponding points are mirror images. So if you have your object, you just flipped the object over this reflection line, and that will be your image. So what you can notice is that the distance between your corresponding points to the reflection line is always the same. So if you take a look at here, this is 1 unit, this is also 1 unit. From here to here it's 2 units, and from here to here it's also 2 units. And then this point to the reflection line, that's 4 units, and it's also 4 units to the other side. So all we know is for reflection, the corresponding point, the distance between the corresponding points to the reflection line will be the same. So let's do some examples together. Oh, well, there's one more concept. Reflection symmetry. A reflection symmetry is a line that divides symmetrical figures into two equal parts. And you can have horizontal, vertical, or oblique reflection lines. And you can have multiple lines in a polygon. So for example, this is one symmetry. This line of symmetry, this reflection symmetry, divides this shape into two equal parts. Okay, and this one divides the shape into two equal parts, the two triangles. This line also divides your shape into two triangles, and same for the others. Okay, so example number 1, describe the translation. So to describe the translation, you want to identify which one is the object and which one is the image. So you're moving from the object to the image. Okay. Then we can find a pair of corresponding points. Let's say, for example, this point and this point. And so I know then from this point to this point on image, it translated 1, 2, 3, 4 units down. So this is 4 units down. And here, that's 1 unit to the left. Now 1 unit left. And you can double check these translations and see if it's correct. So for example, I use these two corresponding points. So again, 1, 2, 3, 4 units down, and then 1 unit left. So I know then the description here works for all of the corresponding points. Okay. Example number 2, draw and label the translation. So 7 units left and 6 units up. Okay, so this is my original shape. And I'll follow this translation for all of the 4 points. Okay, so this one, let's say this is A. 7 units left will be 1, 2, 3, 4, 5, 6, 7 units. Okay, and then 6 units up, 1, 2, 3, 4, 5, 6 will be this point. So that will be my corresponding point. Let's make it A prime. Okay, let's do another one. This one, 7 left, 6 up. So 1, 2, 3, 4, 5, 6, 7, and left, and 6 up. 1, 2, 3, 4, 5, 6. So right here. Okay. And then you can choose to do all of these other points using the translations, or you can use the relationship between the points. So you can see that this point, let me do it red. This red point is two units to the right and one unit up from this green point. So the corresponding point then will be the same, 2 units right and 1 unit up from the green. So let's say this is B, B prime, this is C, and this is C prime. And then this is D, and let's find D prime. So D is 1, 2, 3, 4 units away from A, 4 units right of A, and then 1 unit up. So that's 1, 2, 3, 4 units away to the right, and then 1 unit up will be here. So this will be my D prime. And so I can just use a straight line to connect these 4 points, and that will be my image. Okay. So this is the image after the translation of 7 units left and 6 units up. Example number 3. Rotate the figure 90 degrees about point A. Now, this question doesn't tell you whether it's rotating clockwise or counterclockwise. But we know that if no direction is given, it's rotating counterclockwise. So counterclockwise, which direction is counterclockwise? This is counterclockwise. Okay. So let's use this length as the initial length of reference, this side. So a 90-degree turn will be 90-degree counterclockwise. So it'll be like that. So you're gonna do a right angle, and it's a length of 1 unit. So there we go. Okay. So this will be the side of this length after the rotation. And then we can find the corresponding sides. So for example, this length is this, and we know this base here is 2 units away from this this top length, and it's 1 unit more on the left and 2 units more on the right. So after it's rotated, it's 1 unit more below and 2 units more above. So that's 1 unit more below, 2 units more above. Let's see. From here to here, it's 2 units down and 1 unit left. And so after you rotate it, it will be 2 units to the right and 1 unit down, like that. And then this is 2 units down, 2 units right, so 2 units left, and then 2 units up because of a 90-degree rotation. Everything is rotated 90 degrees. So then we can just connect the other 2 lines. Oops. And so that will be my new image after rotating this original. So this is a 90-degree counterclockwise rotation. Okay, last example, reflection example. So it asks you to draw the reflection image after rotating this object over this reflection line. So this is your reflection line, and remember we talked about reflection. That is, it's always the same distance from the reflection line. The corresponding points always have the same distance from the reflection line. So that is okay. Let's see. So this point here, let's find the corresponding point for this point. This point from the reflection line, it's about half of the diagonal of of this square. So from here to here, it's half of the diagonal. So we can do half of diagonal here. So that is this point. Okay. And then let's do this point. Well, this point, you can see that it's two diagonals from this reflection line. And so if we do 2 diagonals on this side, 1, 2, that will be here. Okay, and then this point here, well, from the diagonal, it's one, sorry, from the reflection line, it's one diagonal, and then we'll do another diagonal that will be here. And notice that um, these points, let me use a different color. Oops. These lines, the lines you make between the corresponding points are always gonna be perpendicular to the reflection line. Okay, you cannot do the point like you cannot do it. You cannot draw the points like this. You cannot have a point over, let's say here. Okay, it has to be perpendicular to the reflection line so that you can have a mirror image. Okay, so now let's connect these 3 points, and that will be this, this, and that. Okay, so my blue triangle here is the image after reflection over the reflecting line. Okay, all right. So that's it for today's lesson. Please try these questions in your workbook and let me know if you have any questions.